The core basis behind advanced AI that we are seeing these days are neural networks. And neural networks have been in creation for more than 60 years. They aren't anything new. But what made them awesome was depth. But here's the catch, just adding layers wouldn't have worked, and it didn't work for many years. Three things had to change first. What separates a shallow network from a deep neural network? A quick refresher, what is a neural network? A neural network is a just layer of neurons. An input layer takes your data, hidden layers transform it, an output layer gives the answer. Each neuron does one simple thing: multiply inputs by weights, add a bias, apply an activation function. Data flows forward, that's forward propagation. And if there's a mistake in the prediction, then the network works backward, nudging every weight, trying to improve it, make minor changes so that you get a better answer the next time. That's backpropagation. So the networks with one or two layers, they are called shallow networks. And deep networks, not a different species. Same neurons, same weights, same forward and backward passes. On the left, you see a shallow neural network. On the right side, you see a deep neural network. 3 or more hidden layers, usually with a lot of neurons packed into each. You can see the difference, but honestly, layer count is the boring half of definition. Here is the half that matters. A shallow network wants its inputs as a vector, a tidy list of numbers, which means that even before the training starts, a human decides what goes in that list. You extract the features, you tell the network what matters. A deep network flips that. Give it raw data, pixels, words, images, and it discovers features itself. Early layers catch simple patterns like edges. Deeper layers stack those into shapes, objects, meaning. Nobody hand designs any of it. So the real headline, with the shallow network, you do the feature engineering. A deep network learns on its own. It tries all sorts of combinations and learns. If depth is so powerful, why did it take 60 years? 3 things had to line up. 1, a breakthrough in the field itself. 2, lots of data. And 3, raw computational power. So factor 1, for years, deep networks kept dying from the same disease, the vanishing gradient. Networks learned by sending an error signal backward through the layers, but with classic activation functions, the signal shrank at every step. Stack enough layers, and by the time it reached the early ones, nothing is left. Those layers just stopped learning. The fix? Simple. ReLU. Negative output, negative input, the output is 0, positive output, pass it straight through. Straight line is the trick. The positive values for the gradient doesn't shrink, so the learning signal survives the trip all the way back. Suddenly, networks with dozens, even hundreds of layers could learn. Factor 2 is availability of data. These deep networks are very data hungry. They can just munch down on the data that you give. A deep network carries millions of parameters. Feed it a small dataset, it won't even learn the patterns. It will memorize the examples, that is overfitting. The cure is huge amounts of training data, and for many years, the data simply did not exist. And the internet filled that tank. Billions of images, oceans of text, curated datasets like ImageNet. That's when the deep learning showed off its superpower. Conventional machine learning improves with more data up to a point, then it flattens. More data, same performance. Deep learning is the other curve. It just keeps climbing. The more you feed it, the better that it gets. Hungry models need a fast kitchen. The factor 3 is simple. Greater computational power. Training a deep network takes an absurd amount of matrix math. Same multiplications billions of times over. A CPU works through that mostly one step at a time. Fine for everyday computing. But in this case, it could take weeks. GPUs rewrote the equation. They were built to render video game graphics, which by pure luck also need massive parallel matrix math. Thousands of cores all crunching at once. Weeks of training collapse into hours. And this is the answer to the question we started with and what made NVIDIA tons of money. Faster training means faster experiments, faster failures, faster breakthroughs, and boom, it finally ignited. So to recap, shallow network 1 or 2 hidden layers, hand-engineered vectors goes in. Deep network, many layers, many neurons, raw data in, features learned automatically, and boom, all 3 catalysts land together. ReLU cracked the vanishing gradient problem, the internet delivered the data, and GPUs delivered the compute. Depth always works on paper, but these 3 made it work in real world. Tell me in the comments if you have any questions or doubts or any topics that you want me to cover. And if you want the next step, subscribe. They're called convolutional neural networks, and the video next is about that.